Hello, this tutorial is going through the GCSE Physics Paper 1 from May 2018, higher paper, and as ever press start and stop or play and pause so that you can have a go at the questions before I go through the answers. Question 3. A student investigated how the resistance of a piece of nichrome wire varies with length. Figure 3 shows part of the circuit that the student used. So as soon as you see the idea of wire varying with length, then you need to cast your mind back to one of the required practicals. Let's just look at question 3.1. So complete figure 3 by adding an ammeter and a voltmeter. Use the correct circuit symbols. Well, first of all, what is an ammeter and what is a voltmeter? So an ammeter is A with a circle round, and that measures the current. And if we think about what happens with current, it's going round our wire and it's moving at a certain speed, or the charge is moving at a certain rate, because links to current, Q equals IT, or I for current equals charge divided by time, Q over T, so the rate of flow of charge. So how quickly it's flowing. So what you need to do with an ammeter is put it in series with your circuit. And that means the current will go through the ammeter, and you need to imagine it like a water wheel spinning round. The faster the current, the faster the water wheel will spin round. But in order for the water wheel to spin round, you need to put it in the water. Same with the ammeter, it needs to go in the circuit. A voltmeter though, a voltmeter, similar circuit symbol, but just with a capital V, and that measures the potential difference, or you can use the word voltage, but try and use the word potential difference. And that measures the push between the start and the end. Now, if we just zoom in on a battery, now each battery or each cell is 1.5 volts. So we've got 1.5 volts on the long side, and the short one has 0 volts, because as the current goes round, it leaves with 1.5 volts and it ends with 0 volts. But the word potential difference is, well, because it starts with 1.5 and ends with 0, the potential difference is 1.5 take 0, which is just 1.5 volts. If we zoom back out again, so in order to measure the potential difference, you have to put it across something. So you need to measure how many volts are going in compared to how many volts are going out. So we need to put the voltmeter across our wire, because that's the thing we want to compare. So the ammeter will go in series and the voltmeter will go in parallel. For question 3.2, describe how the student would obtain the data needed for the investigation. Your answer should include a risk assessment for one hazard in the investigation. So because you're dealing with electricity and current, immediately you can start thinking about the hazard, and you might link the idea to current heating things up. So you might want to just put a little mark next to that for heat. But we need to describe how the student would obtain the data needed for the investigation. So you've got a diagram that you can keep referring to. So at all points, you need to plan and go from your plan. So let's start from the basics. We need to consider our variables. So the independent variable, the dependent, and the control. So the independent is the one that I change. So what are you going to vary? So generally speaking, it's easiest to vary the length of the wire. What are you going to measure? Well, you're going to measure the current. The clue is given to you because you've got an ammeter. You might also want to measure the potential difference. And then linked to that, you might want to measure the resistance. And it's really good at this point to start thinking about the equation. So dig deep and remember that resistance is potential difference divided by current. And you've then got a V, so that's you're going to use a voltmeter to measure the potential difference. You're going to use an ammeter to measure the current. The length of wire, you'll use a ruler, and then it's a case of thinking what you're going to do with the data, so you'll probably end up putting it in a graph. So then you'll be able to, once you've calculated resistance, plot a graph of resistance against length. And then for the control variables, you might just want to make sure that all the other equipment is kept the same. So now we just need to turn it into some words, which then will give us 6 marks. And there we go. There is our 6 marks. But I'd highly recommend planning like I did, step by step by step, and then it's far easier if you plan, just like you would in English, to then write a series of prose, or yeah, I could have equally done bullet points. And if you notice, each one of these could be pretty much a bullet point, so feel free to use bullet points as well. On to question 3.3. Why would switching off the circuit between readings have improved the accuracy of the student's investigation? There's a theme all the way through this, and it's linked to the hazard and then heat loss. So it's all because you don't want the temperature to change. If the temperature changes, that affects the resistance. The higher the temperature, the higher the resistance, the more the particles vibrate, and the harder it is for the electrons to pass through, and that's what resistance is. So the answer to 3.3 would be the temperature of the wire would not change. And then for 3.4, the student used crocodile clips to make the connections to the wire. They could have used a piece of equipment called a jockey. Figure 4 shows a crocodile clip and a jockey in contact with a wire. How would using the jockey have affected the accuracy and resolution of the student's results compared to using a crocodile clip? Now, I always see these sorts of things as spot the difference. So what is the difference between the two things, and then how could it possibly be better compared to the other? So if we just zoom in, what we can see is the main difference is the contact of the wire. So here's the jockey, and here's the crocodile clip. And what you can see is the contact size of the crocodile clip is a lot larger than that of the jockey. So therefore, what we're talking about is the accuracy of the student's results would be higher. But we need to be careful. We need to tick 2 boxes, and therefore the other one is the resolution of the length measurement would be higher as well. So accuracy closer to the true value, and resolution just because it's a finer tip. Here you've got quite a large tip, here it's a lot smaller, so the quantity has a smaller change, so we'd say that's got a higher resolution. That brings us to the end of question 3. Any questions, please get back to me.